Hi, I'm Sandhya Saisubramanian from the University of Massachusetts Amherst. Today I will be presenting our work on understanding user attitudes towards negative side effects of AI systems. AI systems are used in a wide range of applications and have broad societal impacts. However, these systems are rarely perfect, and their behavior may sometimes be considered as undesirable because they produce negative side effects. Negative side effects are the undesired effects of an autonomous system's behavior that occur in addition to its intended effects when it's operating in the environment. The severity of the side effects can vary from mild events to safety-critical failures. As more and more AI systems are deployed in the real world, negative side effects are becoming increasingly common. For example, an autonomous car that is optimizing the travel time to a destination may not slow down when it's navigating through a pothole. As a result, it can cause bumpy ride to the passengers as a negative side effect. A primary reason for the occurrence of negative side effects is because most systems operate based on incomplete information about the environment in which they are situated. This could be because of unavailability of information during system design, or unanticipated domain characteristics that could be discovered after the system is deployed, or cultural differences between the target users and the development team. Since negative side effects are more likely to be discovered after the system is deployed, it is important to understand how users react and respond to negative side effects of deployed AI systems, which is the objective of our work. Our study focuses on answering 4 research questions. First, to what extent are users willing to tolerate side effects that are not safety critical? How does the occurrence of negative side effect affect the user's trust in the system's capabilities? Are users willing to assist the system in mitigating the impacts of side effects? This assistance can be in the form of providing feedback to the system every time they observe negative side effects, or redesigning the environment so that the system's action no longer produces negative side effects, or specifying regions for safe operation of the system. Finally, we are interested in understanding whether users are willing to tolerate some level of suboptimal behavior with respect to the system's assigned task in order to mitigate the impacts of negative side effects. Our study focuses on negative side effects in 2 different settings. First, a Roomba that sprays water on the wall as a negative side effect when it cleans the floor. Second, an autonomous vehicle that does not slow down when it's navigating through a pothole, resulting in a bumpy ride for the passengers. The surveys were conducted on the Amazon Mechanical Turk platform. We recruited 500 participants to complete a pre-survey questionnaire that had 6 questions. The purpose of the pre-survey questionnaire was to assess participants' familiarity with AI systems and their fluency in English. Based on these responses, we invited 300 participants to complete 2 different surveys, one that focused on side effects in the Roomba setting, and another that focused on side effects in the AV domain. Each of these survey questionnaires had 10 questions each. Finally, we had 183 responses for final analysis in each setting. In our study, we described scenarios of occurrence of negative side effects, and we required the participants to select an option that best describes their attitude. To understand user tolerance of negative side effects, we required the participants to select a tolerance level. Our results show that the tolerance varies and depends on the severity of impacts. We were also interested in understanding whether users' trust in the system's capabilities may be affected by the occurrence of side effects. We required the participants to self-report their trust level between low, medium, and high. Our results show that even when the side effects are not safety critical, they can affect the user trust in the system capabilities. Between providing feedback, redesigning the environment, and specifying safe regions of operation, feedback seems to be the most preferred tool that users are willing to use to assist the system. This is possibly because of the simplicity of interaction with the system. Users are also generally willing to allow for a slack on the system's assigned task, meaning that they are willing to tolerate some level of suboptimal behavior so that the system can learn to mitigate the impacts of negative side effects. Overall, our results provide insights into how users may respond to negative side effects of AI systems. Our results also support the design of customizable systems to mitigate negative side effects and improve user satisfaction. Thank you.